Hello, in this lecture, we are going to learn more about hypothesis testing and more specifically t-tests. Welcome to Lean Six Sigma Processes course. And in this course, we're going to look further down on the analyze phase. Um, Whenever you are dealing with a new version of the current scenario, if you are implementing new things and you are wondering whether these new things are effective or inefficient, you should be doing some data analysis, right? And hypothesis testing are going to help you deal with statistically concluding whether the new proposed system is producing better results or not producing better results. So that's what we are going to learn more about in today's course. And t-tests are going to help you compare um, the data that's coming from two versions of your processes. So let's dig down further. More specifically, this lecture is going to show you how to describe and construct null and alternative hypothesis. We're going to learn more about what null hypothesis is and what alternative hypothesis is. And don't worry if you have not taken any stats course more recently. This lecture should be paving the way into the definitions of these two. And we are going to learn more about how to do one sample and two sample t-tests between two different populations. More specifically on population means, by the way. You could do a lot of different statistical tests on, for example, variance or standard deviation or proportions. This lecture is only going to cover t-tests, statistical tests on population means. And after we do that, we're going to see how we can make a conclusion on the ultimate result. And that's when we are going to take a look at the p-value. And hopefully, when your p-value is below certain standards, you will have to come to a conclusion. And as an activity, experiential learning activity, we are going to be doing an A/B testing. And A/B testing is a commonly used tool to decide which version is actually better, version A versus version B. Usually, this is a very well-known technique used in the tech industry, but it can be adapted to any different system. So I want you to focus on the chart or picture on the right of the slide, and you look at a gentleman proposing to his significant others, right? And then if we just assume that currently these two are single, and we represent their status quo in the null hypothesis. H0 here is the null hypothesis, right? They are all single. They will stay single, right? And in the alternative hypothesis, as you can see, the question is, will you marry me? And the alternative hypothesis is the case when these two get married, hopefully happily, right? And look at the focus on the answer that the lady is giving to the gentleman. And lady is saying that I reject the null hypothesis, meaning that she is in favor of the alternative hypothesis, and which means yes, right? Um, One thing to realize here is the null and alternative hypothesis cover all the possibilities. That's something that you should keep in your mind when you're constructing your null and alternative hypothesis, right? Again, the null hypothesis here is keeping the status quo, and alternative hypothesis is adapting the new change, okay? And what is going to be our evidence to look at here? Well, of course, in this scenario, we don't have any evidence, but statistically, we will be doing some data collection and we will be analyzing our data to come to the conclusion of whether rejecting the null hypothesis and switching into the alternative one, right? And in this case, we are going to have a strong conclusion, which is to reject the null hypothesis, or we are going to fail to reject the null hypothesis, meaning that we do not have statistical evidence that we should switch to the new version, okay? And that is the case when we have to stick with our current status quo. I hope this analogy is clear. If not, we will dig further down in this lecture. All right. So hypothesis testing is all about making inferences about a population, right? So we do have a big population. For example, if you're interested in, for instance, average height of all Florida Southern College students, right? And that would represent our population. Well, our population would be the entire set of students attending Florida Southern College. And if we imagine a sample out of that population as our class, then we have limited number of people, but those are still representing the student body of the Florida Southern College, right? And based on our sample, if we take the average of the heights of the students attending this class, we would be able to make an inference about the population, right? That would be making an inference on a single population parameter, which is population average of student heights, right? Sometimes we would like to compare two different populations. So in that case, it will be two different samples from two different populations, and we will be making a conclusion based on our data analysis, right? So hypothesis testing is going to help us do this statistically. So really, what can you do with the hypothesis testing? Well, as a matter of fact, this is commonly being used in the scientific fields and business fields, right? If you look at, for example, Pfizer's and BioNTech's vaccine, they announced on Monday, November 9th, that their COVID-19 vaccine is 90% effective on the instances that they studied on the people that they took into clinical testing. And I'm 100% sure that they asked these simple two questions, and they must have done some hypothesis testing to convince the people at FDA that their vaccine is 90% effective. And when we look at the status quo, we would assume that they ask this question: people who receive the vaccine are no less likely to get infected with COVID-19. This would be the claim that represents the current status quo. And the alternative one would be H1. People who receive the vaccine are less likely to get infected with COVID-19, right? If we, for example, reject the null hypothesis based on the data that they collected, it means that we are rejecting the claim that people who receive the vaccine are no less likely to get infected with COVID-19. It means that when we reject this, it means that we are in favor of the alternative, meaning that people who get the vaccine is going to show strength against the COVID-19 disease. Well, thanks to their science, thanks to their vaccine, and thanks to their clinical trials and statistical analysis, millions of lives will be saved, right? So that hopefully we can go back to normal. So I just want you to, understand that the statistical testing may be seen irrelevant in comparison to basic science. In this case, statistics is actually part of basic science that can make the final statement on crucial technologies like this one, to go or not to go, right? So statistical testing is all obviously everywhere. So let's see another example. Bing, the search engine of Microsoft, they actually are continuously improving themselves. So A/B, this is a version of A/B test. Their software engineers are doing a lot of experiments based on their user data. One day, they asked themselves this question: okay, look at the version A on the top right of the screen. As you can see, when you type, for example, insurance on their search engine, their version A gives you this direct link to their website and no other further links beneath it, okay? And version B, with a tiny small change into improvement, what they did is they took the sublinks on their main websites and they retrieved them on the main search screen as a subdirectory link. As you can see, so please note the difference here. Version A has no sublinks, but version B has several sublinks that usually appear on the main site. And what version B does here, it shortens the way to get a code, find discounts, and look up the company specifics information right on the search, which gives the user ability to go directly into their deep down in the insurance company's website. Okay, and then what they did is they tested version A against version B. They constructed the null hypothesis and alternative hypothesis. And their null hypothesis is people who see direct links in the search are less likely to click on the ad. And their alternative hypothesis is just the other way around. People who see direct links in the search are no less likely to click on the ad. Well, if they, based on the data that they collect, if they reject the null hypothesis, it means that they are suggesting that they should switch into version B. As a matter of fact, their experiments told them to do so, and look at their results. They are able to save 100 million United States dollars just because that they did this switch from version A to version B. See how impactful hypothesis testing can be on a specific company or on a specific process. Well, as we work on our continuous improvement projects, if we have, for example, statistical data, the current version data of the change before the change, if we keep the data and look at the data, and after we make the change and we collect some observations about the alternative version that you're proposing, how do you know whether you did the right thing? And statistical testing, hypothesis testing is going to give you the key to resolve that issue. Okay, that's why we study hypothesis testing. So in a nutshell, again, in the null hypothesis, we put the current situation or the status quo, right? And in the alternative hypothesis, we challenge this status quo. And based on the results of our experiments, statistical experiments, we have the flexibility to reject the H0. In this case, we are suggesting that we should adopt a new system, or we fail to reject H0. In that case, there is not really good amount of statistical evidence that the new system is giving us to support the new system. Therefore, we should be sticking to the current status quo. I hope this is clear. We never accept H0. We fail to reject it. All right. This is critical when it comes to making a decision about our processes. All right. I know another important thing here is that when you're constructing your hypothesis testing, make sure that the two together cover all the range of possibilities in the system. So it will be clear to you. All right. So this is a summary of hypothesis testing, what we should be doing when we are constructing our H0 and H1. What we do is we state the null and alternative hypothesis. And number two would be we start the procedure with the assumption that the null hypothesis is true. And our goal is to challenge the null hypothesis, to collect more further statistical evidence to challenge it. And number four, we either reject the null hypothesis, right? In that case, we reject the null hypothesis in favor of the alternative hypothesis, or we fail to reject the null hypothesis and we stick to status quo, right? If we reject the null hypothesis, then we suggest that we should switch to the alternative hypothesis or the new version, whatever you are proposing.